Hey guys, welcome back to my YouTube channel. So in this video, I'll be doing another example of a expectation and variance of continuous random variables and probability. Suppose that x is a continuous random variable whose probability density function is f of x is equal to c times 5x minus x squared if x is between 0 and 3 and 0 otherwise. Find the constant c and the probability that x is greater than 2. This is another example of a expectation and variance of a continuous random variables problem. Since f is a probability density function, let me write it down, that the integral of negative infinity to infinity of f of x dx is equal to 1. In this problem here, we're trying to find the constant c. So what's given is I'll take out the c, 0 to 3, of 5x minus x squared dx. Now I'll just solve this integral here. So this would be 5x squared over 2 minus x cubed over 3. I can just plug in f of 3 into here. And this would just be 81 over 6. F of 0 would just be 0. So 81 over 6 minus 0 is equal to 81 over 6. But now we're trying to find the constant c, so we can set it up as 81 over 6 times c is equal to 1. And finding what c is, we get c is equal to 6 over 81. Now let's find the probability that x is greater than 2. So the probability that x is greater than 2 is equal to the integral of 2 to infinity of f of x dx. Since we figured out what c is, which is 6 over 81, I'm just going to write down 6 over 81 out of the integral of 2 to 3 of 5x minus x squared dx. Let me just solve this integral once again. It would be 5x squared over 2 minus x cubed over 3. Now I could plug in 3 here. This would be 81 over 6 again. And now for 2, this would be 44 over 6. Now let's subtract the 2. This would be 37 over 6. To remember that we have a 6 over 81, the constant c, on the outside. So now we have to multiply it by 6 over 81. The 6 cancels, and we get 37 over 81. So the probability that x is greater than 2 would be 37 over 81. And this is another example of an expectation and variance of continuous random variables problem in probability.